I had done a paper on the gravitational field of a tachyon. This is a hypothetical particle that would go faster than light.
What's the latest on the Fermi Paradox? There's plenty of time for a civilization to rise up, send out a mission to multiple planets, pitch tent, use local resources to build more rockets, and go to 2 planets, 4, 8, 16.
Astronomers love the Copernican principle. It says your location is not likely to be special. We live around an ordinary star, in an ordinary galaxy, in an ordinary supercluster. You should ask yourself, why am I not a space colonist?
This is StarTalk. Neil deGrasse Tyson here, your personal astrophysicist, and today we are featuring my exclusive one-on-one conversation with my longtime friend and colleague, fellow astrophysicist, J. Richard Gott III. Very deep thinker on all manner of subjects under the sun and moon and stars. Rich Gott.
Hi, Neil. I think that's about the best compliment I ever got.
That's the best compliment.
That's just about the best. Yeah.
Rich Gott, you're a close friend. You're probably my closest colleague friend that I have.
Oh, that's
we've
great.
spent a lot of time together in conversations and dining with family. And we probably met earlier, but we didn't become close friends until Princeton University. I did my postdoc there many moons ago. And you spent almost your whole life on the faculty at Princeton University. So let me just put some of your professional background on the table. You born and raised in Kentucky.
Right.
In high school, did you win some science fairs and things?
I won second place in the Westinghouse Science Talent Search.
That's the big one.
That's the big one.
And now it's called that'd be called the Intel.
Regeneron.
And now
Regeneron.
Now it's Regeneron.
And I won first place in math in the National Science Fair International. Got a trip to Japan.
Now, to come in second place in Westinghouse, did you get to meet the president?
Yes, we met President Johnson.
Wow.
That was that far ago.
Johnson. Which Johnson was that?
And then they asked me to be head judge of that contest for 14 years.
Yeah.
Later.
Who's the most famous person you judged?
That'd be Natalie Portman.
Natalie Portman.
Yes. And I remember her paper.
She was in the Science Talent Search.
Yes. She was in the top 300.
Okay.
But what she doesn't know is she was also in the top 120. I saw her paper. I liked it.
Okay.
That's why I remembered it. I especially liked it.
Even before she was famous.
I had no idea who this was.
Right.
Her paper was judged entirely on its scientific merit.
Mm-hmm.
I had no idea who she was. It was about an enzyme to digest waste paper, make hydrogen fuel. I really liked the project. So.
Okay. And in the movie Thor, she plays a scientist.
She does.
She plays an astrophysicist.
Someone thought to tap into that.
Okay, so you go off to college,
yes.
And you're in the same graduating class as Al Gore.
Yes.
You're like Forrest Gump.
At the time.
Every place you turn, there's some famous thing that spawns off of the moment that you've had in life.
At the time, people said, well, his father was a senator, So people said, man, he's maybe president one day, But if you watch someone come from the bottom up, it's a long way up. And so he did extraordinarily well.
There's a lot of people who you think might become president that never get remembered.
That's true.
So that's a torturous way up rather than getting the result at the end and looking back.
That's right. And Tommy Lee Jones
was also in your class.
So.
Okay. No, they're saying that you're in their class.
Oh, that'd be nice. That's good.
Okay, so after college, you went to graduate school.
Princeton.
At Princeton, got your PhD there.
Then I went to Caltech.
Ran away for a little bit.
And then I went to Cambridge.
University of Cambridge, England.
And then I came back, I joined the faculty.
And you've been there ever since?
Been there ever since.
And I'm delighted that you were there while I...
And likewise, that you were there. When you first appeared at Princeton, I said, this is somebody I got to get to know. So we were friends there.
And we co-taught a class.
We did.
Yes, and we wrote a textbook.
We did.
With a third, the three tenors, someone called us
Strauss. Michael Strauss.
Michael Strauss.
Right.
And here is that book.
Here is that book.
Welcome to the Universe. It's a highly readable textbook of the course we taught.
Right.
So when you look at this, you don't think, oh, I need to take a class with it. You just sit down and read this. This is like a readable
it's for readers.
Coffee table book. One of my chapters in here is Why Pluto is Not a Planet. Chapter 9. I didn't notice that. Did you know that was true?
Oh, I get it now.
I'm only just now realizing that.
Now I get it.
Okay.
Yeah, right.
But in there, was it one of your chapters? We're talking about big numbers. No, it was one of my chapters, but you helped me with one of the numbers.
Right.
Well, I'm trying to find what are some of the biggest numbers we can possibly think of.
Right.
And you can, so how many people on Earth? Okay. How many stars in the galaxy? How many galaxies in the universe? And then you realize you can say, well, how many atoms are in a star in the universe? You add that up, and then you realize you run out of things to count. When there are no more particles left, so how would you ever need a number bigger than that? And then you get big numbers by asking about combinations of things. How many outcomes, how many scenarios? And the number one on that list was how many chess games you can play. And you ran off and gave me that number.
Right.
What did you do? And you're a fan of chess from way back.
Yes, yes. So here's how I did that. People have calculated how many moves there are in a chess game, maximum number. There's a rule that says that you can only go 50 moves without moving a pawn or capturing a capture, or at that point, either player can declare a draw, and let's make sure that they do. You don't want to go beyond that. Okay.
So that would mean it's an end game and you're just wandering around the board.
Yeah, they don't let you wander around forever.
They don't want you to.
When either player is able to declare a draw, let's assume that they do so. Oh, that's the rules. Okay. So the maximum number of moves is 5,900, given that rule. So, you go along and then 50 moves and then you capture a piece. And then you go on another 50 moves. You try to make it last as long as possible. See, that's the longest
we're trying
possible
to calculate
game.
the maximum number.
The maximum number. Okay.
So you just move around, not capturing pieces until you have to capture a piece.
That makes the longest game. And so then you want to promote all your pawns to queens, and to do that, you have to have 4 pawns capture a piece or something. So you get them lined up in rows of 2 each. The knight pawn captures something, it's in front of the rook pawn, and the black does the same thing, and then you can slide them past each other and promote all the pawns.
All 8 pawns go by each other.
Yes, that's the longest.
So my pawns take out 4 of your pawns.
We don't. We try to capture any of the pawns. You try to capture the pieces first.
Get some other piece.
Got
it.
Your pawn gets to capture his knight.
Okay.
And then you got your 2 pawns lined up, and they can slide by the other pawns. Mm-hmm. You want them to all make queens at the end. So you want to make the game last as long as possible. Now, if you want to know how many moves are on the first move of chess, that's 20. You can move each of the pawns 1 or 2 spaces. You can move the knights out. So there's 20 different moves for white. There are 20 replies for black. So the number of combinations on move 1 is 400.
20 squared.
20 times 20. You got to keep multiplying by the number of combinations, okay? You want to find a chess position that has the most possible combinations of moves. And I worked on this to find a position that I thought was...
Had anyone else done this before?
What people had done was they said, what's the most moves white could make? Okay, 218. Some guy figured that out. But the king was kind of stalemated. So they decided, like, 1 move, I resign,
Okay.
So
they hadn't really thought as deeply about this problem as you have.
Well, as to my knowledge, no one calculated the maximum number of combinations.
Okay.
So I found a setup where there were 133 moves for white and 124 replies for black. Okay. And multiplied together, that was over 16,000 combinations on that. And I figured that's pretty much maximal. Each player had 8 queens on the board, not 9. And I had a knight there. You don't want all your pieces there. They start blocking each other. And so if you put the rooks and everything on there, you get less. You get less combinations. So this may not be the maximum combination was, but it's hard to imagine that this number is not enough, because it's better than most of them combinations. Okay, I'm trying to get upper limit here. So you'd have to take this number 16,000 and something, the product of those two numbers, and you have to take that to the 5,900th power. Multiply that out, it's 10 to the 25,000 to the power 25,000. So that's a 1 with 25,000 zeros after it.
Possible games.
Upper limit.
Upper limit.
On the possible games. You can knock off about knowing how many there are at the beginning and how many they'd have to be when there's only a queen and two kings left. You can knock this down to like 23,725 or something. But I wouldn't bother doing that. What's 1,000 orders of magnitude between people? Anyway,
between friends, 1,000 orders of magnitude.
25,000, 10 to the 25,000. It's bigger than a Google.
By far.
That's 10 to the 100th.
Yes.
And sometimes you see people say there's the number of chess games 10 to 120 power. No, it's much bigger than that. And so that's my upper limit.
All right, so your upper limit includes completely ridiculous games.
Yeah, of course. Of course. You can play ridiculous games.
Okay, so you did the calculation properly.
It's a proper upper limit. And then I'm safely below that. We put that in the book.
Yeah, I put that in the book.
Put that right in the book.
Because there was a chapter, one of the opening chapters, just to get people warmed up.
You had the number of quantum states.
Yeah, the size and scale of the universe, just trying to warm people up.
Yeah, right.
And there's just nothing but big numbers just bandied about here. Yeah, so that was our attempt. I taught the first third of the course.
Right.
Michael Strauss, our colleague, the middle third, and you were the final, taking us into cosmology.
Right.
And the like. So do you follow chess tournaments today? I took you to the International Chess Championship?
This was to see Carlsen defend his championship.
Magnus Carlsen.
And you got us a family pass, so I got to be a member of your family for one day. And
this was at South Street Seaport in Manhattan. They had the World Championship there.
The most heartwarming thing to me about that day was that how the chess people loved you. They wanted to take selfies with you. They were so pleased that you, as an astrophysicist, took an interest in their thing.
But I wasn't as good as any of them there. I mean, I had an interest because my son was interested.
We played on a chessboard. He beat me easy. and then, because of you...
But he was like 15 or something at the time.
Well,
Rich,
he won.
I thought you were good.
That's what somebody told me to swim meet once. But anyway, Travis, because of you, you took you backstage. You'll say why, and you got to give my number on the broadcast to the world.
Oh, to tell the world how many possible chess games.
So this is my big contribution to
chess. And I said, what do I have to say here? Because all these people they live this game, and I'm an interloper. But yes, I did tap that content.
And Travis and I got to play a few moves on the actual championship board.
Yes.
And I noticed that when I picked up a piece, they had a little electronic thing in the base. Oh. It was wired. It was a beautiful walnut chess set, but it was wired so that when they made the move, it'd show up on the big board.
For everybody outside.
For everybody outside to see.
It's an acoustically insulated space.
There was like one-way glass. We were looking into the...
Yeah.
It was wonderful.
And I got to make Magnus Carlsen's first move.
That was special. The next day, you got to make the move.
Yes.
That was wonderful.
I guess they give celebrity status to that.
It points to the...
Just to be clear, I didn't choose what his move would be.
You could have started him off bad.
To bring the night out real first? No. So I didn't know I would have this privilege, right? And so he pointed to the pawn that I would then move, and then I did that, and the press was there and the like, and then we exited this hermetically sealed space. But I invited you because I knew you had some interest in background in chess. Yeah.
Well, the big thing in chess now is the AI, because the computers can play now much better than humans can play.
They tell you the first time I beat a computer, I was in college, and I was playing. And the computer was good, but I feel bad how I beat it. should I have emotions about this or not?
You pulled a fast one on it.
I noticed that if I didn't move a chess piece that was highly expected of me, and I instead moved a different piece, it stumped its strategy because it kept thinking he's going to move this other piece because that's going to give him an advantage. And it organized its strategies around that expectation. So when I started moving other pieces, it got flummoxed. And I found it would make mistakes at that point. And I just went in for the kill. And I was able to beat it 3 out of 4 times when before I realized this, I was 0 for 6 or something. But I feel bad. That's not right.
Well, similar things happen in chess today. I mean, first of all, you have to understand that it knows the rules of chess, so it just wants to win. It's happy to win by a little. Get to a pawn endgame, it can win. It's happy. They trained it on Go. They had a program called AlphaGo. They played it against Lee Sedol, who was a terrific champion that they had, and he won only 1 game out of 5. But that was an amazing game because he had this amazing move where it joined 2 areas, and the computer didn't see this move coming. So that's the best move ever played in the sport ever against the computer.
This is Go. This is the territorial game with black and white stones. I mean, well, that's what they are, right? They flip them.
Yes, you try to conquer territory and surround territory.
It's considered way more challenging than chess, is it not?
They say.
Yeah.
Yes.
Yeah, okay.
But anyway, the thing was you might consider a really stupendous program for Go would just conquer, like 3/4 of the field, that kind of thing. But no, it wants to win by just 1 stone, just 1 extra square. It wants to win the easiest way possible. So the games, it's not quite what you think. You want to and in chess.
The computer doesn't have testosterone.
It just wants to win.
Win even by a little bit.
But that's better. That's quicker.
It doesn't want to just conquer and slay you.
No, it doesn't want to chase your king around the board, and it just wants to win.
Yeah.
Some of the games are a little dull. There'd be a lot of fireworks in these computer versus computer games, sacrifices and everything. Then it wins by 1 pawn. So the players today, they are, I would say, machine assisted. They train on the computer. They memorize the openings. They memorize, Carlsen can look at a chess set.
Magnus Carlsen, yeah.
Magnus, he'd say, oh, that was, so-and-so versus so-and-so, 1934. He can memorize all those openings, and then they play with all those openings. But now they know the other players are doing that too. So what you have to do is make a suboptimal move at some point. Drives that person, your opponent, off onto the territory they don't know, and you've practiced that variant. So it's weird because you'd think the best strategy is just to make the best move all the time, but they have to get the human opponent off track.
They're doing what I did to my computer opponent.
They've learned what you learned yourself long ago. You figured it out first.
Yes, because my moves were not optimal. They were just distracting to its strategy.
And they're doing that today.
What's the latest on the Fermi Paradox?
The Fermi Paradox.
Is there emergent thinking on this?
Well,
just let me set the stage here. Enrico Fermi famously declared, where are they? Given the size of the galaxy and the fact that the galaxy has been around a long time, that there's plenty of time for a civilization to rise up, send out a mission to multiple planets, pitch tent, use local resources to build more rockets and go to 2 planets, 4, 8, 16. You can do this in hundreds of millions of years easily.
Right.
Without even warp drives or anything, right?
1/10 the velocity of light.
1/10 the speed of light. Right. Very modest for any modern civilization.
Yes.
Still not us. We're not in that category yet. And if that's the case, the galaxy could and should be teeming with alien civilizations. So where are they? What's the latest?
That's what he said. Where are they?
Yes.
Okay. I wrote a paper on this in 1993. It was called Implications of the Copernican Principle for Our Future Prospects.
Okay.
And astronomers love the Copernican Principle. It says your location is not likely to be special. We live around an ordinary star in an ordinary galaxy in an ordinary supercluster. We're used to this idea. It's been used by Huygens, to calculate the distance to Sirius, arguing that why should the sun be the brightest thing in the universe? These other things are stars, and they're just like the sun. And so what if they're, knowing how dim it was, he got the distance to Sirius accurate to a factor of 20, which was extraordinary.
I didn't know he did this calculation. Brilliant
Huygens.
step to make.
Yes.
So Christian Huygens,
Yes.
a Dutch polymath.
Right.
Yes. And I own one of his books, a charming book, Celestial Worlds Discovered. We just speculates on what life would be like on all the planets. So he looked at the sky and said, maybe if the sun is ordinary, so are these other stars. Is that right?
Right.
So if the brightest star in the night sky, Sirius, is just like the sun, how far away would it have to be as dim as we see it,
Right.
given how bright the sun is
Right.
in front of us today? To even have that thought is
To have
brilliant.
that thought is brilliant.
Brilliant.
Yes.
Okay.
But the most spectacular success of this was when Hubble discovered that all the galaxies were fleeing from us.
Edwin Hubble, the man, not the telescope.
Not the they named it after him.
Yes.
Anyway, they're all fleeing from us, and the further away, the faster. It's a homogeneous expansion away from us. We did not go fall for we're not going to say we're at the center anymore. We're not going to fall for that again after Copernicus. We're going to say, why would we be in the one special galaxy for which all the others are fleeing? No. If it looks that way to us, it must look that way to everyone. You live on any galaxy, you've got to think that you're the center, and you've got to see it all of them expanding away from you. Then you get a homogeneous expansion, like pennies on an expanding balloon. Each penny sees all the others moving away from it, and it thinks it's at the center. And then you get the homogeneous models of general relativity, Big Bang models. And Gamow and his students, Herman and Alford, then calculated that there would be hot in the early universe, and that we could see the microwave background radiation left over from that today.
All of that based on this assumption.
That you're not special. And you get all of that. And then this prediction was that there'd be microwave background radiation left over from the Big Bang of 5 degrees. And I worked with Princeton and Wilson in graduate school, did a project with them. I observed on the telescope. They got the Nobel
Prize for that first measurement.
They discovered the microwave background, 2.7 degrees. This is like predicting that a flying saucer 50 feet across is going to land on the White House lawn, and one 27 feet across actually shows up. This is the most extraordinary prediction in astronomy, and it shows how powerful the Copernican principle is.
Can I slip in a quick story there?
Sure.
I was on the NSF panel to advise the president on who should get the Presidential Medal of Science.
Oh, yeah.
This is under Bush. And George Gamow came up as someone who could earn this. And I'm there on a panel with biologists and geologists. They don't know this prediction. They don't. And so I strongly made the case for George Gamow's prediction, given how fundamental it was to all of cosmology. And I think he was still alive but not doing well. And I'm proud of myself for succeeding at this. And he was awarded the Presidential Medal of Science.
Wow.
And I think his relatives came to pick it up. And part inspired by our conversation just about how much of a brilliant extrapolation of very basic information about our universe that was.
Right.
Yeah.
He invited me to dinner once. My mother knew a friend of hers that knew his wife, and when I was in Colorado working one summer, I got to go over to his house.
As a student?
Yeah, he picked me up in his Rolls Royce.
What?
And he loved Rolls Royces because once the axle broke, and Rolls Royce sent out a team to fix it, and he said, "Well, how much will that be?" And they said, "Rolls Royce axles do not break, no fee."
Well,
So
when I visited Cornell, I was picked up
by Carl Sagan.
Sagan in his Porsche.
He had a Porsche.
Yeah, he had a Porsche.
Well, they had that in common.
Okay. That's my who picked me up in what kind of car story.
You got an equally good one there.
Yeah.
Okay.
So
That's
sorry, I
good.
interrupted. So where were you?
So my paper, 1993, which people should remember, here's its answer to the Fermi question. It's real simple.
just to be clear, you're purely invoking the Copernican principle to arrive at this conclusion.
Yes.
Not fundamentally differently from the way Gamow invoked the Copernican principle layered onto the data available to him at the time. Okay.
And Huygens.
And Huygens, yes.
Right. So here's the answer from the Copernican principle, and it's very simple. A significant fraction of all the extraterrestrial and intelligent observers must still be sitting on their home planet, or else you'd be special. If there's a giant galactic empire out there that we don't know about, they've conquered the whole galaxy and they're just hiding, you know, they don't want the likes of us to know. We're in a little experiment for them, you know.
That would make us special.
Because if you're an intelligent observer, you should be one of the people in the big one.
Okay.
In fact, you can say if you're a person on the world today, you should likely be born in one of the countries that's above the median. Half the countries in the world had, when I looked at this, a population less than 7 million. You're born in America. That's one of the 3 big countries. You don't have to be in the biggest country. I had to mention this to Stephen Hawking once. He said, according to this principle, I should be from China. I said, no, that's a minority of the people on the earth. You should be above the median, which is 97% of the people living on the earth live in countries above the median. The little bitty countries with small populations, you're not likely to be from there. You're likely to be from a random place.
And what did he then say?
He smiled at me. That's the way Stephen Hawking was. He gave me his characteristic smile.
One time I had dinner with him and I asked him a question, and it takes time. I mean, plus he's eating, but he has to spit it out because his throat doesn't work, but he tastes the food. And he's typing out replies with his eyes, right? On his device.
Right.
And I said, how come Isaac Newton didn't figure out how to stabilize the solar system, and he needed Laplace to figure out perturbation theory to show that every time a planet goes around, it's not tugged out of its orbit by Jupiter? Because Newton was upset about it. He didn't know. He didn't have an answer.
Right.
In fact, he credited God for coming in and fixing things every now and then. So I posed that question to him. And then 15 minutes later, out comes the answer. It's, you can't think of everything.
I know. That's great.
That was a dewdrop of wisdom. And then he went on to say, Einstein didn't think of black holes.
Right.
You can't think of everything.
That's right.
People got Nobel Prizes off of black holes.
Right.
That he didn't predict off of his own theory.
He predicted gravity waves.
That got Nobel Prizes too.
That's right.
Crumbs off his plate.
He didn't even get it for general relativity.
I know. That's great. That's great. Okay, so let me restate what I think I understand is your point.
Yes.
With the Copernican principle, as published in 1993 in Nature.
Right.
So powerful is this idea that we're not special.
Right.
In a statistically large enough sample of things, that if all the aliens were colonizing all the planets, we'd be one of those aliens colonizing the planets.
You should ask yourself, why am I not a space colonist? You and I are continental colonists. Africa was the home colony.
No, you were a colonist.
You were a colonist. You were born in New York. We didn't colonize
Don't bring my
North
skin
America.
color into this colony thing.
No. Okay. I'm talking about we're living in a colony from Africa.
Yes.
Okay.
Traceable
we both
there.
Born in and the majority of the people on Earth today are, I'll call them colonists because they came from
the majority
the original
of people on Earth.
We're not from the home
Their lineage
continent.
is not from that location.
That's right.
They arrived there ultimately.
That's right.
With Africa as the point of origin.
That's right.
Okay.
We didn't colonize them. We are colonists living in the colonies established by the continent of Africa.
Africa. Okay.
That's our home planet.
Okay.
Now you see.
So you analogize the galaxy to the surface of the Earth.
Yes.
Africa is
the home planet.
The home planet, and all these satellite places humans are living.
Yes.
Would be all the planets across the galaxy.
Yes.
The Copernican principle says we are most likely living in one of these places.
Yes. Because so many more people do.
Because so many.
You see, there's so many non-special places for intelligent observers to be, and only a few special places, by definition, that you're likely to be in one of the many non-special places, one of the tiny number of special places. It's just that clear.
Okay.
Now, for example,
You're saying all the aliens out there are just like us?
they don't have to be just like us.
No, just in terms of statistically. There's their home bodies on their home planet.
If most of the intelligent observers in the universe are not living on their home planet, why
And
aren't
we are
you
an
one of
intelligent
them?
observer, then we should not be living on our home planet.
That's right.
There you go.
And the fact that we're still on the Earth tells us something. For example, what's the chance that we will colonize the whole galaxy? There's 1 billion habitable planets out there. The Copernican principle says the odds against us doing that in the future are 1 billion to 1 against. Why? Because if that's the truth, if that's what happens, what's the chance that you are living on the first planet out of 1 billion that people live on? 1 billion to 1 against. And let me make this give you another example. I know that there's 11 people born in Antarctica. That's all. Are you born in Antarctica?
No.
They're born south of everyone else. So you're not likely to wake up and find out that you're the most southernmost persons ever born. You're not one of them. There's only 11 of them. There's 8 billion of people out there. So you're not likely to be one of them.
Yes.
So this puts some constraints on our future prospects. Now, if you ask me, can we become a multi-planet species, like 2 planets, like us and Mars? Well, if that happens, you're on planet 1 instead of planet 2, there's a 50% chance we could do that. Let's do that. That might as much as improve our long-term survival prospects of our species by a factor of 2, because we'd have 2 chances instead of 1.
Okay, I was never a fan of that as an argument. I think we should be a 2-planet species just because it's fun, not because for survival reasons.
Well, I gave a talk on this.
Yeah.
Elon Musk was the other person giving the talk.
Yeah.
And I said, my spiel,
Yeah.
it's good for our survival. We have some lifeboats.
Yeah.
You know, like a comet
Eggs in
might
more
hit
than one
us.
basket.
You store your books. You don't store them all in the Alexandrian library. It's going to burn down. Protect as well as you. The only copies we got of Sophocles' plays are the ones that are stored elsewhere. Life has used this to help survive, spread out, multiply, you know. I gave my talk and he gave his talk. He said, well, I like those survival arguments, right? But I thought we could just go for fun. He said exactly that.
He famously said, I don't want to die on Earth, I want to die on Mars.
Not on impact. He said that.
I missed the second half of that sentence.
It's an important half. Okay. But after that, he said, I like that talk. You know, you can hear him on tape saying that. I like that previous talk. That was my talk. And since then, he has definitely used the survival argument. In fact, Carl Sagan wrote me once. He said, I think you've come up with the best argument for going to Mars, even though I wrote a book on it, gave 10 different reasons. This one seems really good. So these space colonies are a very good bargain because you can send like 8 people, 30 people, and they can live there on indigenous materials and chemicals that you have there. Mars has an atmosphere and so forth. It's a great bargain because they do all the work. And it's not that you're going to send 1 billion people there. No, that's not happening. But you can send a small number of people there. They can grow, doubling in population over the years. And so it's a great bargain, and it's something we certainly should be doing for our survival benefit.
That's why I disagree.
You'd rather just stay on Earth. Well, what happens if we have a really bad epidemic on Earth?
Because it's not that I disagree. It's not that I disagree. I'm a practical guy. Okay? I'm a dreamer when circumstances justify it.
Okay.
Otherwise, I just tell it like it is. Okay? You want to pitch tent on Mars, grow a civilization there, so the humans are on 2 planets. So if something bad happens on one planet, we have survivors on the other planet.
There we go.
All I'm saying is, everything bad we can think of that could possibly put life at risk here.
Yes.
The effort to prevent that, to me, it seems, is less than shipping 1 billion people to Mars.
No, you don't ship 1 billion people. You slim a small number. You know how many people
so
colonize?
fine. Okay, so you put some fertile people on Mars.
A few.
Fertile people on Mars. They start making babies. Okay, and
Leave them alone after that.
okay, after 100 years, let's say there's a colony of 1,000 people. Let's say.
Wait 600 years. Wait 1,000 years.
1,000 years.
Yeah. Okay.
All right. How long will it take for them to get billions? We'll have 10
You don't
billion by then.
necessarily need billions.
All I'm saying is
Over there.
All I'm saying is you have two planets. Now something bad is going to happen on one planet. Is the other planet just going to say, "Oh, we planned against this. You all just die, and we will carry forth the genome." That's not how this is going to play out. You're trying to protect the species in case something bad happens on one planet.
You should do everything to do that.
If you have the power to live on two planets,
yes,
you're not going to allow the other planet to die. You're going to ship them over or fix the problem in your bio laboratory or deflect the asteroid. If you have the power to ship people to Mars and terraform it, you have the power to deflect an asteroid that might put life at risk on Earth. And it seems to me you have the power to reverse any geoengineered problem that we created for ourselves on Earth.
People worked hard protecting that Alexandrian library. In the Titanic, they had a hard time getting people to go off on those little dangerous lifeboats out in the water. It was comfortable on let's wait on the Titanic. They had a hard time getting the people to go in the first boats. Mars is not as habitable as the Earth. But like life's living comfortably in the ocean, okay? Out on the land, very dangerous.
For them.
For them. If life didn't go out there, we wouldn't be here as land animals. The ocean is always going to be better.
I liked an analogy you gave that our spacesuits are like
eggs. It's water in there. It's like it's taking the sea with them. Our blood is sort of salty water, bringing the nutrients to our cells,
So an egg can't survive outside of its shell yet.
The chickens.
It can't do it.
Right.
It won't come out until it can.
That's a little spacesuit.
It's a little spacesuit.
Right.
So if I have on a spacesuit, that's my egg. And I'll be in that until I can live outside the spacesuit.
The budget that we would spend on sending people to Mars, you got one entrepreneur that wants to do it.
At least one, yeah.
It's a small amount relative to GNP. And the thing that gets us may be something that takes us by surprise.
That's the only argument I can possibly embrace, is that there's some unforeseen thing that could put life on Earth at risk, and you want to be on two planets. But everything we can foresee, it seems to me would be easier to solve that than to ship people to Mars after you've terraformed it. People said, "Oh, we're trashing Earth. We need an Earth backup plan." Whatever it takes to turn Mars into Earth has got to be a greater effort than to turn Earth back into Earth.
Living on the land is harder than living in the ocean. The species that go extinct are ones that are like on one island. Right? We got a whole universe out there that we could go, that we're standing on the shores of this universe, as you would say, as you have said. And are we going to go out there?
The surface of the Earth
is like the shore.
Is the shore
that's
of
Carl.
the cosmic ocean.
Okay.
Yes.
Yeah. So I say
probably Andrean. She has.
It's a smart thing to do to go to Mars, and it's something we could do in our generation. I'm just saying.
Okay. So, Rich, over the years, you've shared with me exotic ideas about how the universe got here, but they're in the trash bin of failed.
That's true.
Brilliant ideas that have failed. But I remember two of them.
Yes.
And one of them, because it's still a mystery, where did all the antimatter go?
Right.
Because in the early universe, if you have a pocket of energy and it spontaneously becomes matter through E equals mc squared, you get a pair of particles, a matter particle and an antimatter particle. And as the universe cools, these pair-produced particles should permeate the universe, or then sort of come back together, annihilating the particles, and we'd have just a universe of photons.
Right.
Okay? But we don't. We have matter.
Right.
We have all the photons, but we also have matter that doesn't have antimatter counterparts.
Right.
So some symmetry law got broken in the early universe, a cherished symmetry law.
Right, right.
That for every matter particle, you have an antimatter particle.
Right.
And you told me of an idea that there's some tunneling of the antimatter into another universe. What was this?
Well, this was an idea I had in 1974. It was an early attempt to find out what might have happened before the Big Bang.
Okay.
Inflation does a better job of this.
That predates
today.
inflation, just barely.
It predates inflation.
Just barely,
yeah. Okay.
Because the inflation idea came out during the era of very high inflation.
1980s.
The 70s
right.
into the early 80s.
So the story here is that I had done a paper on the gravitational field of a tachyon. I found an exact solution for the gravitational field of a tachyon. This is a hypothetical particle that would go faster than light. Only faster than light.
Lives faster than light.
Has to be going fast. You can't slow it down to light speed, you know. You see one traveling here, it could have infinite speed, you know. Its world line could be simultaneous in some reference frame. Okay. And I found a very interesting general relativity solution for this. And it had a Cherenkov cone of radiation, gravitational radiation trailing behind it like a sonic boom.
Yeah.
There was a cone of gravitational radiation coming behind it.
That's because it's moving faster than the speed a gravitational wave would move.
That's right.
So then it makes a shock wave.
A shock wave, right. And this is expanding behind it. But in front of it, there was a collapsing gravitational wave of, these are called advanced waves. These are ones that go backward in time. Photons go forward in time. That's an asymmetry in the universe. Photons go forward in time only. Shake an electron here, photon goes to Alpha Centauri, gets there 4 years later. Doesn't come from Alpha Centauri 4 years ago. When you shake an electron, electromagnetic waves don't come in from infinity and meet you there. That would be photons going back to the past. This tachyon solution lives in a universe that's time symmetric. Photons can go either to the future or to the past. It goes along a straight world line because it's not accelerated because the energy coming in from the Cherenkov cone in the future is in the front is being made up for by the cone going out the back. If you look at a cross section of this, it looks like two blades of a pair of scissors that are tipped at a small angle and they're moving at speed of light. The intersection point can go faster than the speed of light. Like you can close a pair of scissors, the intersection point can move. That doesn't transmit any energy.
It's not an actual thing moving.
It's not transmitting any energy or information faster
Mm-hmm.
than the speed of light. So this was very interesting because it had that property.
Well, so when you close a pair of scissors, the point at the vertex of the closure is moving faster than anything that's part of the scissors.
That's right. Like you tip them at right angles. You move 1 foot forward this way and 1 foot forward this way with the other scissors. The intersection point moves square root of 2 further down the line. Mm-hmm. And nothing's really moving faster than the speed of light. So I had a model where there was the Big Bang at the center and the matter particles went into the future light cone of that event. And they all went up here.
To become us. To
become an open universe up here that would expand forever. The antimatter particles went backward in time because Wheeler showed that a positron was equal to an electron going backward in time. This was an idea he called Feynman excitedly over the phone. This
is John Archibald Wheeler.
2:30 in the morning.
Student of Albert Einstein.
And then Feynman was his student. He called him up. He said, I know why all electrons have the same mass. They're all the same electron. The world line just zigzags up and down in time. Goes up as an electron, back as a positron, up as an electron, back as a positron. Imagine you have a tapestry that's woven on vertical lines with one spool of thread. That thread goes up as an electron, comes back down as a positron, up as an electron, back down as a positron. And so you're seeing all these electrons and positrons, but they're still the same world line of that one particle, okay? Here, if you look around, you see many, many blue threads.
Because every electron has identically the same mass.
It's the same electron. This is what
in this model is the same electron.
This is what he was saying. Now this doesn't work because we got more matter particles than positrons.
Yes.
It has to be an equal number for this to work.
If it were that universe, we would see positrons and electrons moving forward in time.
Yes. A positron moving forward in time is an electron going backward in time. They're the same thing.
So therefore, it's the same electron,
Yes.
But we only see it at the
cross-section
intersection point in the
of
present.
our epoch, yes, at our epoch.
So all the electrons are just passing, they're
going through.
Our moving slice through time.
Right. So it's a wrong idea because you got more electrons than positrons. Also, you can get a virtual pair to form in the vacuum. And suddenly there's an electron-positron pair. It lasts for a little while and then it annihilates again. And Feynman showed that these existed in the vacuum and so forth. And you had to use them calculating, the magnetic moment of certain things and so forth. And so we know that it's not all one electron. Okay. So I had the matter
because
going,
we're seeing electrons do other things is the point.
Yes. And here's an isolated pair you made out of nothing. That's a little loop of string. It's not connected. It's not connected to the other. It's not all part of one piece. So that has to come from the physics of the electric field and so forth. Okay. I mean, when I was at Caltech, I audited Mr. Feynman's course on quantum electrodynamics. I didn't do the homework. I just audited, sat in the back. And when he got to this point, he said, when I figured out that I could use the electrons, the positrons, as electrons going backwards in my Feynman diagrams, I nearly fell off my chair. So this was a very important part of Feynman diagrams. And so then the tachyons would go, the antimatter goes in the past light cone of this event, and then the tachyons go out toward the present of this event, that big space between the absolute future and the absolute past. So inflation does a much better job of this, frankly.
So was that the most brilliant idea you've had, just happened to be wrong?
That happened to be wrong.
I guess how brilliant could it be if it's wrong?
Well, I thought of bubble universes. This was in 1982. Okay. Guth had this problem of how does inflation end uniformly. He wanted to boil water on a pot and have it turn into steam, have the vacuum energy of the early inflating universe turn into particles. He wanted to do that all at once. Then the universe would be uniform. But unfortunately, it would form bubbles, and that's not uniform, and we don't see that. So my answer to this was, we live in one of the bubbles. It's a bubble universe. It expands. It turns into an open universe. It's and from inside the bubble, you just see toward the past the uniform vacuum, and you don't see the other bubbles yet. And so this is a solution to this problem. And Linde came up with the same idea a few months later.
Yeah.
And then there was Albrecht and Steinhardt, again in short order. And so their thing, they did particle physics with it as well as general relativity, and that became what's known as new inflation. So that's a better idea.
Okay, because it had some truth to it.
That's always good, yes. And so but let me tell you this. The Higgs boson has this Mexican hat potential you've seen. It starts off with a large vacuum energy. You're at the top center of the Mexican hat. You're a marble on top there. You roll off, and you land somewhere in the bottom brim of the thing. And that's where we are today. Not very much vacuum energy. And the boson can oscillate then, and that oscillation, that gives you a positive mass for the Higgs boson, okay? Because it's concave down there. But in the early universe, it's convex. And this means that m squared, the mass squared, is a negative number. That means that it's an imaginary mass, and that means it's tachyonic. It's like a tachyon in the early universe. So when the vacuum decays, you get something called a tachyon condensate, and it's like you've created tachyons. It's turned into tachyonic Higgs bosons that behave like tachyons. But instead of having a wave function that's sinusoidal, they have a wave function that is exponential. And so they decay very quickly, and they don't last very long.
Exponential decay.
Exponential decay, you know. So some people say, well, it's not really a free tachyon, you know. So, but Witten's written papers on tachyonic thing, and my student, Matthew Hedrick, has written papers on tachyonic condensate in the early universe. So maybe tachyons have a role in the early universe still.
I'll keep them on my radar.
And recently,
On my past or my future radar.
Neil Turok has proposed that we have a boundary condition on the early universe. It's like a mirror. So you look back into this mirror, you see the mirror image of us is the antimatter going the other way. It's not really there. It's a mirror boundary condition. So he's coming like that. And I did a thing with Li-Jing Li. You've seen this. There's a little time loop at the beginning of the universe. Like there's a tree and it has a trunk and branches are coming off the trunk, more and more inflating universes. This is Linde's picture. Li-Jing Li and I said, what if one of the branches simply curls back around and grows up to be the trunk? Then you have a little microscopic time machine there. The virtual pair is like a little time machine. Goes up as an electron, comes back as a positron. It makes a little loop.
Don't you talk about this in your book?
Yeah.
Time Travel in Einstein's Universe?
Right. The only self-consistent solution, if you got a little time loop at the beginning, and we found a stable quantum vacuum state for this, the only stable solution is the only self-consistent solution, I should say, is when the photons go only toward the future. It solves that problem, why the photons go only toward the future.
Which is what we observe.
And the temperature in this loop is 0. You can calculate the temperature in there. There are no particles at all. And when you come out, you start seeing Hawking radiation. It heats up because you can't see all the other branches. And so the universe starts off in a low entropy state and goes to a higher entropy state. That could explain the entropy error of time. It would be a great prediction for our theory if no one had noticed it. But unfortunately, they've noticed it, so it's only a post-prediction.
Post-diction.
Post-diction, we would say, yes. So it has a number of interesting features, and there's about 6 different ideas out there.
Okay, all right.
And we're one of them, but
all right.
This is what you do if you're a theorist.
You were the first to introduce me to the concept of a Jinn particle.
Yes.
Just give me a fast explanation for that, because this fascinated me.
Well, there's a movie called Somewhere in Time.
Yes, I know that one.
And
Christopher Reeve is in
Christopher Reeve. He goes to this place up in Michigan, big hotel. I've been there. And he fell in love with this actress he saw a picture in there. I love this girl. I got to meet this girl. He said, well, she's died in 1908, unfortunately for you. So he goes to his old professor who talked about time travel.
His old physics professor.
Yeah, physics. How do you do it? Well, long story short, he's able to go back in time, meet her, they fall in love, and so forth. Before all of this happens, what motivates him to try to go back is there's an old woman, strangely, that comes up to him, and she hands him a gold watch, and she says, "Come back for me." And he doesn't know who this woman is.
But I think it was a locket of some kind. Not
it's a watch. It's a watch.
You sure it's a watch?
Yeah, it's a watch. It's a time travel movie. It's a watch. And he looks up this actress to see who she is. Oh my God. It's this actress he fell in love with, the picture he saw in the thing. She's an old woman. She came and, wants me to come back for her.
And she had handed him this.
The watch.
The watch. Okay.
He's got the watch. He takes the watch back with him. Okay.
Back in time.
He meets her, they fall in love, et cetera, et cetera. They're planning their future together. And then...
Because he successfully goes back in time on the advice of his physics professor. Yes.
That's right. Mm-hmm. He's got the watch with him. She says, "Oh, that's an interesting watch you've got." He hands it to her. She's holding it. And then he sees a penny that he's brought with him that he shouldn't have from 1979 or something. This breaks the spell, and he just...
The time travel...
He just goes away and he's back in the present.
He forgot to swap out his currency to be appropriate
he
for the
wanted
time.
to. He had to do everything authentic.
Yeah.
He got the old kind of fashioned clothes and everything. But they forgot that there was some coins in the coin pocket. So that broke the spell. It's not really physics here. But anyway, I broke the spell and then he's back in the present. He can never get back. But now if you look at the watch, she then has this watch in her hand. And she takes that watch, she gets old, and she takes the watch and she delivers it to him. He brings it back in time.
And gives it to her.
So the watch had no association with a watch factory. It's a circular world line. This is called a Jinn particle.
Jinn.
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 It's like a genie.
Okay.
Jinn. And it has a circular world line. It has no...
No one created it. No one destroyed it.
Right.
It lives in a time loop.
In a way, the virtual particle is like that. because the electron and positron pair is formed and then disappears. It's a little loop. It's just sitting there. It's formed.
Okay, so once you explain this to me, I got to then realize that in Back to the Future,
yes,
Marty is playing a tune by Chuck Berry. Chuck Berry's cousin, who was hired to perform at this dance, hears Marty play.
Right, you are.
Okay.
Right.
Here's Marty play.
Right.
The Chuck Berry song.
That's right.
And gets on the phone, calls Chuck Berry, and says, "Hey, Chuck, this is the sound you've been looking for. Check it out." And he holds it up.
Yeah.
And there it is.
The song itself is a Jinn.
The song is a Jinn
Only the song itself. That's
Correct.
a Jinn. I didn't notice that.
I didn't get that.
I didn't get that.
So am I allowed to call a non-material object a Jinn thing? It's a song that was never written.
Yes.
And it was never created.
Right.
It lives in this loop.
Absolutely. Now, my comment on that would be, and in a time loop, in a time machine, you can have an electron that goes around in a complete circle, and just because it's going toward the future all the time. It's curved space-time. It's like Magellan went west. His crew went west all the time, and they got back in Europe because it was a curved thing.
Yes.
So this can occur.
Do you know the story about his scribe, or whatever they call the people who kept notes on the ship? Pigafetta was his name.
Oh, no.
He was an interloper, a wealthy Italian guy who just bought a seat on the trip.
Yeah.
And he kept very good records of every day.
Yes.
Okay, which you can do.
Oh, yes.
As, you know, when the sun hits the planet, a day has gone by.
Right.
Comes around, and he thinks it's Monday.
That's right.
Or whatever, but everyone else says it's Sunday, or whichever order this was.
That's right.
And he's thinking that the townspeople are playing a practical joke on him.
Right. Oh, that's a good story. Yes.
So this is the discovery of the need for an international dateline.
Right.
And it happened on Magellan's voyage.
Right. So you can have a Jinn particle that's an electron, one electron. You can have a Jinn particle that's more complicated, like the watch. And I would just say the watch is less probable to find. Like you have a virtual particle, it's electron and positron. You could have a virtual, Leonard Nimoy and his antimatter counterpart form and then disappear again. That's less probable to happen than the single electron.
So you would agree with me that this song that Marty was saying, that's a Jinn song.
That's a very good insight.
Jinn song.
Yes.
Okay. That's because of you. I wouldn't have thought that.
Oh, well.
I wouldn't have thought to think that.
You thought of that.
Okay.
Yes. Right.
So, Rich, I've kept a list my whole life of movies that portrayed genius behavior in people. I was always just intrigued by them.
Yes.
I thought it'd be fun to show your kids.
Right.
Just that there are things you can value, like being smart is one of them in life.
Right.
And one thing I couldn't wrap my head around, somehow everyone believes that if you're really, really, really smart, you can move objects with your mind. Like, where does that come? What? Who says that?
Yeah.
They're not saying they can just solve problems faster or better than you. They can come up with solutions that others couldn't. No, their mind is going to make tops spin in the middle of a table. No, I'm not accepting that, because get the smartest person you've ever known, met, or heard of. If there was any chance being smart would have those powers, there'd be suspicious things happening in their presence, even in the mildest of senses. But no, somehow screenwriters can't resist. Storytellers cannot resist this.
Right. This happened in the movie Lucy.
Lucy, yes.
She's
Scarlett Johansson.
She's getting smarter and smarter because she's taking some drug. She's using more and more of her mind.
Right.
She's
using powers that her mind already has, were just never tapped by her.
People are coming for her with guns. She just levitates them to the ceiling, knocks the guns down.
And she's walking down the street. She changes the color of her hair.
I love this movie. But, my wife's named Lucy. She's very smart, but I haven't caught her levitating things around the house yet. I mean, it's not something
If you come by, you're floating on the ceiling.
The iPhone is not just 10 times better than the Cray computer from the 1970s. It's 100,000 times basically more memory, 100,000 times as faster, and it's not levitating anything. So I agree with you.
There's another movie that actually preceded Lucy. It came out in 2011, I think. It was called Limitless.
Okay.
It had Bradley Cooper, one of his early.
Oh, yeah.
And he
took a pill.
He took a pill.
Yeah.
And that felt a little more real because he could figure things out. The stock market, it showed a actual mental acuity going up, not power over matter.
Right.
So.
Right.
And there are others. This is irrational. I think it's irrational fascination with childhood genius. Will we ever get over this? I mean, come on now. Really? Really? Okay. So your 7-year-old is doing calculus. So everyone has to crowd around the 7-year-old and presume that they will one day become an adult that'll get 5 Nobel Prizes.
Yeah.
But that never happens. Okay.
Well, sometimes it happens.
Let me say, it doesn't happen as often as people expect it or want it to happen, given the level of resources directed to such people.
Yes, that's true.
Did Natalie Portman, who was judge of her science fair project, did she become a scientist?
No, but she found something she liked better.
This is my point.
And she's not wasting her time doing that.
This is my point.
She found something
we
she liked
see what
better.
a kid does really well, and all the adults crowd around, and we force them into these things. They let him be a kid. The psychologists want to get a hold of your kid, and someone else says, let him be a kid. Otherwise, they won't get socialized. They won't,
There's a movie Gifted like that.
Gifted, yes.
Yeah.
Yes, a girl.
Little Man Tate is sort of that theme,
Yeah, that Jodie Foster. They're real stars in these movies.
Give the kid love and a good support and let them do what they're interested in.
But meanwhile, you have the authorities who want to sweep the kid away. And again, on the assumption that kids like that become adults like that.
When Gauss was 6, the teacher, he'd done something naughty, and she made him add up all the numbers from 1 to 100. And he said...
This is Gauss, the brilliant Gauss.
Yes. Mm-hmm. And he thought about it. He said, well, I could pair the 1 with the 100. That's 101. He pairs the 2 with the 99. That's 101. And there are 50 pairs like this. And he got the answer, which is 5,050, And he just says 5,050, But there's a method to it, you see. But he was 6. So and Mozart, there's some people that are like this, but a lot of people flower later. They show up later. So all different things can happen.
Right, so the teacher gave Gauss that task just to
punish him.
It was like to
take
shut up and
day.
go in the corner and figure this out.
He came back right with the answer.
Right, didn't even, in the time it took him to walk to the corner, he had the answer.
Feynman said once, if he lived back in the day of quantum mechanics, he might have done better, like Heisenberg, I mean, he would have had more opportunities back then to discover even more important laws of physics, depending on where you live.
Did he say this?
Yes.
Yeah, so he thought he'd born in the wrong time.
When he introduced Heisenberg, who showed up at Caltech, he said, if I'd been back there, I might have done something even bigger.
He might have been somebody.
Might have been more. Might have been more. That's right.
Then they have the autism movies where they have what they used to call
savant.
Yeah, the savants.
Remember,
you have Rain Man. You got.
There are people who can remember what happened to them on every day of their life.
People plot what day of the week, a date that you give them, no matter where that is.
Right.
Pull it out of their head.
Right.
I'm intrigued by all of these movies. Another one had John Travolta in it. Phenomenon. I enjoyed that one. He was hit by lightning. Because you need some reason for your brain to be different.
Yes, right.
He's hit by lightning, and then he's really smart.
Right.
But they couldn't resist, and he's levitating things as well. He couldn't resist that.
That's right.
Okay. As a kid, I remembered reading Flowers for Algernon.
Oh, yeah.
Only later to learn it became a movie.
Yes.
Called Charlie.
Yes.
And I think that had Cliff Robertson in it.
Right.
So in this, as a kid, I think he was mentally very delayed, and there was an experimental drug that they would give to him.
Right.
And they decided to test it on him because it had worked on mice.
A mouse. Algernon.
Right. And they gave the drug to Algernon, and it did the maze much faster and better, and remembered it and everything.
Right.
And so they gave it to him, and I remembered this because I was old enough to feel this.
Right.
Because all of his friends made fun of him because he was not smart like anybody else. Okay? He would do dumb things or stupid things, and they're just mean people. Bullies and things they would make fun of. Into adulthood.
Right. Absolutely.
Okay? He had a janitor job, and they made fun of him. They put dough in his
he
locker.
was a good-hearted person.
Yes,
He was
he's
a good-hearted person.
You just see these mean people.
Yeah,
and then they started doing the drug on him, and he got smarter and smarter.
Right.
And he started outsmarting the people who were mean to him.
Yes.
And then they rejected him because he was no longer someone they could poke fun at. And then we learn how the story ends, right?
Drug wears off.
Well, the mouse dies.
Oh, well, worse. Yeah. Okay.
but anyhow, I don't know.
The remarkable thing to me about that movie, and Cliff Robertson won the Oscar for it.
Yes, he did.
Was when he was smart. I don't know what they did or what he did as an actor, but his eyes sort of twinkled. I mean, his eyes looked alive in a way that was abnormal. He managed to encapsulate the look of someone who was incredibly smart. I don't know how he did this, but I saw it there, and his performance playing the smart person was very extraordinary. I thought because he looked at it, and there was no levitating in that movie. He just could solve complicated problems. He was trying to find the cure for his disease, as I recall.
Right. I just don't think just because if you have a smart kid, other people shouldn't come in and tell your kid what they should do with their smarts. I have a visceral objection to it.
True.
Of course, I don't mind a system that wants to find the smart people in the group. No problems with that at all. However one defines being smart. But if you now put people in a category and define that category in such a way that no one else can participate, even if they try hard and succeed, then there's something wrong with that. To me, it doesn't sit well within me. When I was a kid, I was identified by the U.S. Department of Education, Office of the Gifted and Talented. And by being so recognized, I had access to certain opportunities. And I thought to myself, they call it gifted and talented. Gifted. What is a gift? Somebody hands you something. Did you earn it? Did you work for it? No, a gift. And I wanted that branch of the U.S. government to be renamed Office of the People Who Work Hard. Office of the People Who Are Devoted to Succeeding. That way, if you're not branded as gifted, you can say, well, let me just try harder. I'll try harder next. I'll study harder. And yes, some people will learn faster than others for whatever, biochemical, neurological reasons, but so what? I'll work harder than you do, maybe to even be equal to you. But if I keep at it, maybe I'll be better than you. And the system had no way to find that. And so, can I give an example?
Sure.
So in high school, we all took the SATs, right? I think they existed in your day. You're not that old.
Yes.
Okay. So I took the SATs. My verbal score was like, okay. It wasn't bad, but it was nowhere near any level where a teacher would say, watch him, he'll go far. Teachers pass judgment on you based on your performance on exams that either they administer or the state or the federal government give you. Okay. No teacher would have said that at all. After my third book, and I had a column for a major magazine, I get a letter in the mail from the Educational Testing Service. And Richard, where are they based?
Princeton.
Princeton University.
That's right.
You live in Princeton, don't you?
Right.
Yeah, okay. So the Educational Testing Service, purveyors of the SAT.
Yes.
Just to show you what kind of a grip they have on us all, I got to the letter and I said, did they rescind my scores? Did they, this is like after my PhD, okay? And it says, Dr. Neil deGrasse Tyson. I said, oh, okay. They must know at least that I have a PhD earned long after their exam that I took. So I open up the letter and it says, Dear Dr. Tyson, we recently read one of your essays. We want to excerpt sections of it to include in the reading comprehension section of the verbal SAT. Will you grant permission?
Right. This was a victory.
There's what I wanted to say, and there's what I did say. You know what I wanted to say? I want to say, F you. Okay? It's like, first, I don't get your high score. No teachers pointing to me. I will have any literary ability in the future. Now you want to use my writing as an exemplar to test people on your exam? Something's wrong here. Okay, that was on the inside. On the outside, I said, yes, I gave him permission. But I was very disturbed by the fact that things can unfold that way.
Well, they were.
And by the way, that was even before my best-selling book, okay? Which was on the bestseller list for 81 weeks, okay? None of them would have, and me, it's not like I was a late bloomer. I knew what I wanted to do with life early, just like you did. Okay?
Right.
I was in the science fair and I owned a telescope and I was in the astronomy club and I was in the physics club. It's not like I later on figured out how to put myself together. So that's why these people who are identified early by some system of measurement as being deserving of who should be coddled and supported and funded going forward omits whoever else is left behind.
Got to give them credit. They were smart enough to ask you to write the essay. let me give you an example.
Yeah.
Bob Vanderby and I wrote a book.
Bob Vanderby, he's our co-author on
the 3D book.
The 3D version of our textbook, yes.
Yes.
He's an engineer, photographer extraordinaire.
He worked on this 3D book with us. And
3D objects in the universe, yeah.
Yes. I would like people to start playing 3D chess, you know.
That's above my head.
On a 4x4x4 grid.
Yeah,
you know.
the 8x8 serves me fine.
What's the same number? 4 by times 4 by 4.
Okay.
I'll just speak up for 3D chess.
Okay. So I didn't know 3D chess has only 4x4s.
Well, it was proposed in 1851 on an 8x8x8 board. Then it was popular in 1907 on a 5x5x5 board. I think they should use a 4x4x4 board because it has the same number of places for the pieces to sit. You know how it works. The rook can't just go north, south, and east, west. It can also go up and down.
Right.
You know. So anyway, we worked on this 3D book together, and Bob and I had written this book, Sizing Up the Universe.
Wonderful.
And
book.
we asked you,
ways to compare different relative sizes of things in the universe. Brilliant.
Right. And we
exercise.
asked you to write a blurb for us for the front of the book.
Did I write a blurb?
You did.
Was it good?
Well, here it was. You said, a feast for the eyes, a banquet for the mind. And I said, how did he come up with that? That's terrific. That's amazing. That's an amazing sentence. You know? A banquet for the mind? Weren't you? You know, this is terrific.
Well, thank you. Thank you.
It's a terrific sentence.
Yeah, no English teacher would have said any of that.
Well, there you go. We appreciated your expertise in language.
Well, I love words. Words are fun. The right word in the right time in the right place, there is no substitute.
And if Shakespeare couldn't find that, he invented the word.
Yeah, why not?
That's right.
In my latest book, I invented 7 words.
Really?
Yeah, not to show off or anything. There was a sentence where I needed a word that didn't exist, and so I created it.
There you go.
I have one word in the Oxford English.
What is that?
You don't know this?
No.
You
got one in?
I got one in.
This is
not on purpose.
contribution.
It just is.
Yeah.
You need a word, and you have the word, and now
Okay.
it's the word for when the sun sets on the Manhattan grid.
Oh.
Manhattan Henge.
That's right. That's terrific. People now congregate there.
Yes.
And they
block traffic for reasons other than Con Ed digging holes in the street.
Right.
And, or
great.
police activity. They're stopping traffic for the universe.
Right.
So
that's great.
I had ambition to just learn and enjoy the universe my whole life, as did you.
Yes.
And I didn't want people telling me what I could or couldn't accomplish. I found that to be so counterproductive.
Oh.
We should have ways of measuring people's ambition, because ultimately I think that's where you win in your life's trajectory from childhood into whatever is the professional status you seek.
Okay.
All right, so Rich, we're about to rank films that feature genius.
Okay.
We're going to rank them. Now, the categories are S for superior, and then A, B, C, D, E, F. And all you have to do is
these are grades plus
You're
A plus.
I guess the S would be an A plus.
Let's call it an A plus.
Yes, and since F is below an E, F is really bad because who knows what an E is, right?
Okay.
The E is not excellent. E is below D.
No.
Where would you rate the movie Charlie? Cliff Robertson in a role.
That's an A because of his special performance when he was smart. I thought he was very effective.
When he was smart as an actor, he had a whole different facial.
Look to his eyes.
His
they
eyes
twinkled somehow.
Okay.
I don't know how he did that.
Okay.
Okay.
That was good. I'd give Charlie a B.
Okay.
Not because I didn't enjoy the movie or think it was important or have meaning to me at the time. I just thought it didn't fully explore what genius could be.
Okay.
It was a very narrow storyline in the context of genius. Revenge of the Nerds.
I'd give that a C.
C.
I don't know. I mean, I vaguely remember that movie, but I don't. They got even with everybody.
They got even with everybody using their brilliance.
I guess so. I don't remember much about it. So.
Oh, okay. All right.
I saw it, but I don't remember.
Okay. I'm going to give it an A.
Okay.
Because
they outsmarted the other people.
Because
okay.
It came at the exact moment where people learned that maybe being a nerd is cool.
Okay.
Before then, nerds got wedgied by the football quarterback.
Okay.
And what happened in 1984? The Apple Macintosh gets released. All of a sudden, computing comes into your home, into your classroom. And the jocks and all the beautiful people, if they want to do well on their homework or on they need to be friends with the nerds. Okay. So I view that as transitional.
Okay.
I was invited to give the commencement speech in the year 2000 for the Bronx High School of Science.
Yeah.
And I titled it Revenge of the Nerds. Because all of a sudden, the richest people in the world were the nerds. Not the oil tycoons or the steel tycoons.
Right.
It was the geeks.
Right.
Who would have been rejected from all the party invitations. So I viewed it as an important movie in our culture.
Okay, then.
Even if as a movie, it might have only been a C.
All righty, then. Okay.
But I got to give it an A.
Okay.
Cultural importance. Cultural importance.
Right.
Okay. Let's keep going. Real genius. If you didn't see that, I'll just rate it.
I don't remember that.
Okay. S.
Okay.
Oh my gosh.
I didn't see that.
S. I mean, think of Revenge of the Nerds, but a better film.
See.
It had Val Kilmer in it.
Oh, okay.
And it's just some really smart kids just out of high school into Pacific Tech. Okay.
Oh, what was that? Yeah. Which school was that?
The Pacific Tech. Real genius was a celebration.
Yes.
Of just being smarter than everybody else.
Oh, okay.
Look at how many movies are celebrations of people who are more athletic than everybody else.
Right.
Who are prettier or handsomer than everybody else.
Right.
This was a movie of people who are smarter than everybody else.
There you go.
And I found one error in it.
Yes.
There are others, but this one was... Okay. There's a vending machine, and his friend comes in and sees him with this lab cutter, and he's cutting this cylinder. The cylinder is smoking. And he says, "What are you doing?" And he says, "Oh, I'm cutting nitrogen. So solidified nitrogen." Okay. Like, what is he doing? And then he gets a little circular disc out of it. Then he puts it in the vending machine. He gets the candy out.
I see.
That's good. That's good. And the mistake they made was they said, "What are you doing?" He said, "Oh, it's liquid nitrogen," which of course it isn't. It's solid.
Oh, I see. Okay.
So they messed that one up. But just so finally, being smart could be fun.
Okay.
Fun and irreverent, rather than weird and whatever else you might do with it. How about, do you see Good Will Hunting?
Yes.
Yeah, what do you think of that? With Matt Damon as the janitor turned math genius?
That's an A with some reservations.
Why?
Well, I like it's a deeper movie,
Yes,
I think.
it is.
This is, and the psychiatrist, Robin Williams won the Oscar for that, and he was very good, and they explained his genius work in psychiatry, And so the quibble I had was that the field medalist in the thing, he said, "I am nothing. This is Sarsgaard, you know. He said, I am nothing. This guy's, compared to this guy, I'm just Matt Damon. I'm nothing. My work is worthless.
The actor Sarsgaard,
Sarsgaard,
who's the professor who had been a Fields Medal winner, which you only win if you're younger than 30. So he's later in his career.
Yes.
This is the highest achievement in mathematics.
Yes. I know Fields medalists, and I think they think their work is important, but they're thrilled when they see somebody even better. It doesn't diminish what they've done, but for example, Roger Penrose came to Princeton one time. He gave a talk. He said, let me tell you what Stephen is thinking. This is Stephen Hawking.
Okay.
I mean, he's not going to give his own talk. Okay. He's going to tell you what Stephen is thinking.
So good people.
So they can be good. They can feel great about the stuff they've accomplished, but recognize somebody of even greater accomplishments.
So in this movie,
they can be happy with that.
They didn't interview enough field medalists to know how he would have behaved in that situation.
I thought. Okay. Yes.
So that's you're going to drop it a score for that reason?
Well, I said an A with reservations.
Okay, all right, A. I'd give it an A because of the story was more interesting and it was richer, and it's a townie. You know, if you're a townie,
yes,
no one gives you any respect. If you live in the town of a very highly respected university, in that case, it was Harvard. Right. And you had the snooty Harvard students.
Right.
So I thought it captured that very well, having seen that and lived that. Okay, let's keep going. Lucy with Scarlett Johansson. How would you rate that?
Love that movie, but it's crazy. As you say, you don't levitate things if you're, smart. But I love that movie. She needed to get an operation. She went into the operating room. She looked at the X-ray on the wall, killed the patient on the operating table. He's going to die anyway. You need to operate on me. She held him at gunpoint while they operated on her. I mean, she didn't feel the pain, I mean, it was a fabulous movie. I'd give that an A.
What would you give it, an S? A+?
Well, it went a little too far. I'd give just an A.
Okay.
Yeah.
All right. Let's break format here just for this one exception. Queen's Gambit. It was a TV miniseries on Netflix. I would actually give that an excellent or a superior, because, as would I. Because they went to the trouble to get world champions and things to produce the chess moves for the movie. They were real chess moves. Real chess moves. How did you know this? Well, they told you. Okay. If later, behind the scenes, they bragged about doing this. But, that was very authentic. Because they're all just actors and they just do what the script tells them. And she practiced moving the chess pieces like she observed. The way professionals they move them fast and kind of, they have a certain style. There's a certain wrist action and a certain nonchalance about moving them if you've played chess a lot. She studied that. And she is Anya Taylor-Joy. Right. Yeah. That was terrific. So I agree. This would be an S right at the top. A superior, top of the line. And it was localized to being a chess genius. But it still explored what that meant around people who don't understand you and what your abilities are. Right. And you got a little bit inside her head where you saw her play chess on the ceiling. I like to see a movie that tries to explain to you how they got this idea. Inside the head. And they rarely do that. No, they don't. How about Phenomenon, John Travolta? He gets hit by lightning and he gets really smart. I'd say that's maybe a B. C, B. I enjoyed it while I watched it, but it didn't keep calling to me. Right. So I'm going to give that one a B because I like John Travolta in that role. It just didn't stick with me that much. Okay. All right. Gotcha. There's some biopics here. Yes. Okay. So these are like real people who had sort of. What do you think of The Man Who Knew Infinity? Math genius. I give that the top mark. That's an excellent. Yes, it's S for super. Super, yeah. I mean, Dev Patel and Jeremy Irons. Jeremy Irons. I love him in anything, by the way. We interviewed Jeremy Irons after that movie came out. I know you did. Yeah, he's in our archives. Right, StarTalk archives. Yeah. I mean, I heard all these stories from Littlewood, who was played by Toby Jones in the movie. It's a true story. It shows you also how hard Ramanujan worked. So he was an Indian mathematician who was discovered only when he wrote a letter to the University of Cambridge to Hardy, the mathematician. Yes. Can I come and work with you? Can I come work?
And they did a great thing on partitions, which is the ways of summing up to a given number for very high numbers. And they made a big contribution to that field. And I might mention, I mean, the amazing thing about Ramanujan was he came up with these incredible formulas. You know, your man Newton, he came up with an infinite series that gave equal to pi, okay? And the first term in his series, the biggest number that appeared in the formula, he's got a lot of n factorials and things like that in it, but the biggest number that appeared in the formula was 6, okay? And the first estimate from just the first term was pi equals 3. And then you add the second term, it gets more accurate. And each one, it converges quite rapidly. It beat all the old...
You're talking about Newton's formula.
Newton's formula. It beat all the old polygon formulas. Okay. It was a new infinite series, new method. We use calculus. So Ramanujan has this formula, and he just presents it, you know. And it's an infinite series like Newton's. And but it's got these big numbers in it, like 26,390. There's an 1103. There's a 9801. There's a 396. What do these numbers have to do with pi? What is this formula? And the first term in his formula is accurate to pi to 1 part in 13 million. And then it gets better after that. And people were just astounded by these things that he came up with.
But you want to rate it high because he's smart, or did the movie do a good job conveying?
I think the movie did a good job of conveying that.
Well,
yes.
Let me hold your feet to the burner here, because you've got a beautiful mind.
I give that a super also.
You get it, see? Because that was...
And it also explained a bit how he thought of the idea.
Yes, you get inside
I like
his head.
that.
And we're talking about...
Nash.
It's Russell Crowe playing John Nash.
Right.
Now, my office at Princeton, when I postdoc there, when we first met, John Nash would walk by every day.
Right.
I just see him walk by, kind of staring up into the sky.
I went to see them film the movie.
Oh, yeah?
Okay. And everybody was excited. Everyone wanted to see Russell Crowe, or, you know, everybody was excited when the filming was there. And as I'm driving in, I see Mr. Nash walking, you know, out of the physics building, you know. I just see him on my way in. And when I talking to some of the people at the concessions, I said, you know, I saw the real. Everybody's here to see Russell Crowe, but meanwhile, the real Nash, John Nash, is walking about a block away from here. It was a bit surreal.
Okay, so let's order these then. Let's take back your grade for the Man Who Knew Infinity. Okay?
Yeah.
Let's just take it back for a moment.
Okay.
We have The Man Who Knew Infinity, Ramanujan. Right. We have IQ, also filmed at Princeton.
Yes.
Which portrayed Einstein.
Right.
Walter Matthau was in that, Meg Ryan. Then we have The Imitation Game.
Yes.
With
Cumberbatch.
Playing Alan Turing.
Alan Turing, yeah, sure.
And, of course, The Theory of Everything with Stephen Hawking. All of these are
true
epic
stories,
movies,
yes.
True stories, mostly true stories, with lead actors, like marquee actors playing in these roles. Just rank them for me.
Well, let's
let me
see.
let me add another one. Let's not be so science-oriented.
Okay.
Amadeus.
I think I might even put Amadeus first.
I agree. Amadeus. Next.
Yes, among those. Now, I should comment that Redmayne's performance of Stephen Hawking captured his personality. It was great.
Okay.
I mean, they could have done more of explaining how Hawking got these ideas a little deeper.
Which they didn't.
But I think his personality, and he did a terrific job, and he won the Oscar for that.
Okay, so let's put that at an A, okay, because you're ranking these. Okay. Next one up.
I guess I'd put Beautiful Mind ahead of an Imitation Game.
So would I think.
Because they explained how he thought of it.
That made you feel for the character more, because you got inside his head. Right. Okay, then Imitation Game. Okay.
Yeah.
Do you know where Imitation Game comes from, that name?
No.
They didn't say it in the movie.
They didn't? Okay.
Yeah. His original paper.
Oh.
On...
Was this about imitating artificial intelligence?
Yes.
Oh.
his original
Okay.
paper
Okay.
on the Turing test.
Turing test, yeah, sure.
He didn't call it the Turing test. He called it the imitation game,
Right.
where you
Okay,
interact with a
sure,
computer,
Sure.
and the computer pretends it's a human and makes you think it's human. And if it can make you think it's human, that was counted as official AI.
Turing did for computer stuff what Gödel did for mathematical. It showed there was computer programs that you couldn't call an algorithm that would say when something would end because you'd get into these logical self-contradictions.
Did you know Gödel? It was at Princeton? Did
I
you
saw
overlap?
Gödel.
You saw him.
I saw him. We had the same doctor actually, but I saw at one point. But
he was at the Institute for Advanced Studies.
I saw him walking.
Yeah. Okay.
That's Gödel.
Okay.
I was impressed.
Okay.
He did general relativity. The first time machine in general relativity did. That wasn't even his main field.
Okay.
He did the rotating universe that you could do time travel to the past. It was the first solution, 1948, that showed that general relativity could have time travel solutions.
And then he kicked math in its ass after that.
Well, I think he did that before.
Oh.
He'd already done that.
All right. So where would you put IQ?
I guess I'd sort of give it a B. I thought it was nice that, you can find somebody really smart in the gas station. That is possible, Okay. But I thought it was charming.
Yeah, but charming is not enough to get a high score.
Well, so that's why I'm giving it a B.
No, see, I'd give it a C.
Really? Okay. Well, we're sort of
relative to these other biopics?
Yes.
Come on now.
Okay. Well, I gave it a B. I may be easier or greater than you.
Okay. Oh, how about searching for Bobby Fischer?
Maybe that's even the super category. It's for this one great line.
That had Ben Kingsley in it, right?
Ben Kingsley is playing the chess
coach
guru, and I think your son studied with the actual guy.
My son, who got good at chess when he had already studied with him when he beat you.
He
played you in chess.
Yeah. Okay. So
he beat you pretty quickly.
Thanks.
I have a photo of you just holding your head like this, looking at the chess. Okay.
So there's this one line in the movie that's just magical. He's trying to convince the father that he should let his son be under the tutelage of him because he, Ben Kingsley, wanted to see the next Bobby Fischer because he loved chess so much. He wanted to see what magical creations, just like you're looking for a work of art. He wanted to see what the next Bobby Fischer would be like. And he goes to the Manhattan Chess Club. And this is the best chess club in the country. And he says, now these are, over there is the American champion. Over there is a Chinese grandmaster or something. And over there is this grandmaster or something. He says, you won't find Bobby Fischer here. He's asleep at your home in the bedroom. Oh, and the father says, I'll sign him up. I'll sign him up to work with you.
It's also based on a true story.
It's a true story. And the interesting thing about that actual kid was that he got bored with chess after a while. He did not become the world champion, but then he became a world champion in Tai Chi, this martial art.
I did not know that.
Which shows that he had a talent for devoting yourself to something.
To being good at
something. And getting to be the champion.
And there's a bunch of movies that have kid geniuses, right?
Yes.
There's Matilda, that was fun and entertaining. There's baby geniuses, that was a little weird. That was kind of a fun premise, that baby talk can be decoded into actually fully intelligent conversations they're having with each other.
Right, okay.
I thought that was an interesting premise. But these are more sort of cartoony storylines than anything else.
Right.
But anyway, I think we ranked enough of them there. None were a D or an F. D, E, or F?
No, I think people that take that project on as a challenge are probably going to try to do a good job.
Do a good job with the right budget and right stars.
Right stars.
All right. J. Richard Gott III.
Thank you, Neil. You're
Thanks
great.
for coming by.
One of my great friends in the world.
Thanks for coming by.
Thank you, Neil.